Good morning, dear students. Last video that we have seen some characteristic of waves. Amplitude. Amplitude is a maximum displacement from the mean position. That is what we have seen. And phase. Phase is nothing but the positions of a wave. That is what we have already seen. Wavelength is the consecutive distance between two crests and the trough. That is what we have already discussed. Time period is the time taken for one complete cycle of the wave. Frequency of the wave that we have discussed, and what is how the phases differs from position to position. That is what we have already discussed. Now we are going to go for the today's topic, wavefront. What is wavefront? In fact, wavefront is defined as locus of all points having same phase at a given instant of time. Phase, that means, for example, if a wave is propagating from one place to another place, like this, if the wave is like this and it is propagating from one place to another place, okay, so it is propagating like this. So it is propagating like this. So when it propagates, 2-3 waves propagates together. For example, one is starting from this middle and another wave is starting from here, like this, okay, and one more wave which is starting from down, okay. So these are all some waves which is propagates together. When it is propagates, the front of the wave, that is a wave front, which shows over here. Can you see this? This is a wave front, which are all in the same phase. This is similar to this, okay, which are all in the same phase. If we join these phase together, if we join these phase together, that is called a wavefront, okay. So if we joining this, okay, so if we joins together, that is called wavefront. Okay, this is considered as a wavefront. This is how we can consider how the wave is propagating. By the propagation, how we can consider that it is a wavefront, okay. Now, and one more additional thing, a wavefront is always normal to the light rays. So if we say here, this is wavefront and this is wave propagation. These both have the angle of 90 degrees. So it is always perpendicular direction. A wavefront does not propagate in the backward direction, because wave propagates in one particular direction, it will not come back. So that the propagation is only one direction, okay. And you can see here, the wavefront moves from one place to another place. This is a wavefront. If you see from a perpendicular direction, if you see from top, this is how the wavefronts are looking like. Okay, wavefronts, it is looking like a straight line. Okay, it will be always looking like a straight line. Okay, so there are 3 types of waves are there. One is spherical wavefront. Second one is plane wavefront, that is linear in shape. Third one is cylindrical wavefront. There are 3 types of wavefront is there. First, we are going to see about spherical wavefront. Spherical wavefront, if you see here, so when a source of light is a point source, when a source of light is a point source, the wavefront formed will be a spherical wavefront. For example, point source means if we throw a pebble on a silent water, what will happen? The ripples will take place. The water will start flowing from one place to another place. So this is called a point source. So while the waves are propagating like this, if we join the wavefront, what will happen? It will be looking like a circle. For example, I'm going to draw the diagram for you. So if you see here, this is a source where the light glows or where we throw the pebbles. Okay, from here the wave will start propagating from one place to another place like this. It will propagate like this. Okay, and the second one, it will be propagating like this. And third, it is propagating like this, and fourth side like this. All 365 degrees, the waves will start propagating. While it propagating, what we will do usually, the phases will be joined together to calculate the wavefront. Okay, phases we are going to join in here. So how can we join the phase? If this is the first phase alone, if we join together, it will form a circle. Second, the second phase alone, if we join together, means it will form a circle. And third, if we draw like this, it is also forms a circle. So this is the first circle, this is a second circle, this is a third circle. Like this, circle which is forms over there. Example, as we have seen, it is a ripples in water. In water, you can see there are lots of ripples which will create over here. So ripples which is in water only, that we can consider for concentric circles as a spherical wavefront. Okay. Next, we are going to see about plane wavefront. For plane wavefront, we will take an example of rays which is coming from sun. Okay. If the rays coming from the sun from infinitive, if we put a wavefront line over there, as we have seen in the example, it will be looking like a straight line. Okay. So when a small part of spherical or cylindrical wave originates from a distant source like infinitive, then the wavefront which is obtained is known as plane wavefront. Okay. Next, we are going to see the cylindrical wavefront. Cylindrical wavefront is nothing but as a light source which is coming over here. On the path of the light, we will be placing one slit. Slit means a single opening in the center. Other sides, the light cannot enter. So through this slit only, the light will come out. While the light is coming out, the edges of the slit, the light rays will start bending. Okay, bending of light which is happening on the edges. This is called diffraction, which we have already studied for it. This is called diffraction. For example, in a figure that we can see that rays of light falls on a lens. After coming out from the lens, they will converge at a particular point. That I will show you in the next slide. Before that, here I will draw a diagram that you will understand how the cylindrical wavefronts are created over here. As you can see here, this is a slit. This is a straight slit that you can watch over here, small opening. So here, light rays which is coming as a plane wavefront is coming. Okay, plane wavefront is coming and hitting the slit. When it reaches the slit, from this slit, the light will started bending here. Diffraction will happen like phase, like how it is moving. Okay, diffraction is happening. Okay, and like how it is moving over here. Okay, diffraction which is happening. It moves like this. So what we will do usually, we will join the wavefronts. Okay, wavefront if we join means what will happen? What is the shape which is created? That is called a wavefront, right? So this is the phase which we are joining it together. And the second phase which we are joining it like this. Okay, and the third wavefront. Okay, and the next fourth wavefront. So like this, if we join means it is similar to that of the diagram which is placed over here. Okay, so we can consider that how the wavefront which is creating in here. Okay, so similarly, when the light ray which is coming from a distance, if we capture through the lens, what will happen? That is what we are going to see in the next diagram. So this is a lens, the straight wavefront which is coming out here. And after passing through the lens, what will happen? It will converge in one particular place. Wavefronts are getting bent to converge at a particular point. So wavefront is getting curved after coming out from the lens. How it is becoming like a curve? That I'll show you this as a similar type of diagram that we can draw for lens also. For example, I'm drawing this as a lens. Okay, so this is a lens, plane wavefront which is coming. Okay, right? This is a sun rays which is coming over here. So when the light ray comes and crosses the lens, what will happen? Usually if it is considered as a wave, it will propagate and it will converge in one particular point, right? And the other end also, it will come and propagate and converge in one particular point. Okay, this part also, it will propagate and converge on one particular point. And this side also. So what usually we'll do, we will join the faces together. Okay, so if we join the face, what will happen? It will be looking like this. So this is how we will join the face. So can this similar, how the lines becoming curve, that you will understand from straight curve to bending, straight line to bending curve, how it is transforming, that you will understand by using this diagram. Okay, so these are the three different types of wavefront which is present over here. So go through this video once again, so you will understand better when it comes to wavefronts, different types of wavefronts. Rest of the thing we'll see it in the next video. Thank you.